Hey there, today we are going to be finding surface area without nets. So that means we're going to look at a 3D figure and see if we could calculate the area of the outside of it. So remember, if you're thinking of something like maybe a gift box, we're basically calculating the amount of wrapping paper that you would need. Let's start with number 1. So this is a rectangular prism, and I could tell that because all the sides are rectangles. There's no triangles at all, so it can't be a pyramid. In a rectangular prism, there's always going to be 2 pairs of sides that are exactly the same. So in something like this, the front side and the back side are going to have the exact same area. And when I'm talking about the front and the back, I'm talking about this guy right here and this guy right here. Now, if you visualize a different part of it as the front and the back, because we all kind of see these shapes differently, that's fine. You would actually end up with the same final answer, so it doesn't really matter. So looking at those green rectangles, I have to determine what numbers to use to find the area. I see a 2 here, and I see an 8 here. Now, this line, I'm going to use a little bit of a thicker pen. This line that's 8 is going to be the same as this line that's 8. So I can jump the 8 over there. So I can see to find the area of the front piece, I'm going to do 2 times 8, which is 16. And that's all the work I have to show. And if you want to use a calculator, if they're harder numbers, that's fine too. And the back is going to be the same. 2 times 8 equals 16. Part of showing work is writing down what numbers you're using. When I'm looking over your work, there's no way for me to know what numbers you're using if you don't write it down. So the front and the back is one set of the numbers. Now I'm going to erase my markings from that because when I start to find the other sides, it's going to be in my way. So I'll make this a little thicker so it stands out. Okay, another pair of sides would be the left and the right. To me, the left and the right look like this side of it. And then there's one on the other side that I can't really highlight without interfering with the one I just did. I'm going to try my best to kind of go around it. But this guy back here, it is a full rectangle, but I don't want the green and the yellow to overlap and then you can't see what I'm talking about. So the left and the right, think for a minute which numbers you might use to find the area of one of those 2 sides. I would use the 8 and the 7. So 8 times 7 equals 56, and it's going to be the same for both of them. Okay, now I'm going to erase my markings because I have one more pair of sides to find. And that would be this guy and this guy. And I would refer to those as top and bottom. I know that I'm using the B abbreviation twice, but up here, since it's paired with the F, I know it's front and back. And here, when it's paired with the T, I know it's top and bottom. So take a moment, see if you can figure out what numbers to use here. I think it's going to be the 2 and the 7. 2 times 7 equals 14. 2 times 7 equals 14. The answer to this is going to be whatever this plus this plus this plus this plus this plus this equals. You got to add up all those answers. Take a moment, use a calculator, add up all those numbers. You can pause the video if you need more time. When I added them up, I got 172. The units that we use for surface area are meters squared. Even though you think it's a 3D item, and so maybe you would use meters cubed, but that's only for volume. That's not for surface area. Surface area has area in the title, and so therefore we use area units, which are squared. And then that's how you would do a problem like this. So when you're doing any kind of surface area problem, the sides to consider would be front and back, left and right, top and bottom. And that's just a really helpful list to keep handy. If you take a screenshot of that, or if you set yourself up with like front, back, left, right, top, bottom, you can copy and paste that on any problem and use it. Okay, so now I'm going to do number 2 with you guys. So I'm going to copy and paste that. Oh, I didn't want the image. I just wanted the regular. Okay. Now this is a triangular prism. I know it's a triangular prism because there are 2 bases that are triangles and the rest of the sides are rectangles. Triangular prisms have 1 fewer side than rectangular prisms. So one of these is missing on this shape. Take a look. Does this shape have a front? Does it have a back? Does it have a left and a right? Does it have a top? Does it have a bottom? Which side is it missing? The correct answer would be that it's missing the top. The top is just this straight line here. There's no face on the top. Triangular prisms only have 5 faces, not 6. So I'm going to cross off top. This is not going to be part of my answer. I'm going to be able to find the rest of these. In a triangular prism, we can't assume that all the sides are the same like we did for the rectangular prism. The only sides that we get to assume are the same are the 2 bases, which are the triangles. So if I can find the area of this, I know that it's going to be the same as the area for this. Now, what would you call that? Would you call that front and back, or would you call that left and right? The answer is it doesn't really matter. To me, it's front and back. So I'm going to do the work for this in the front and back section, but maybe you would call it left and right. I don't know. And it won't impact the final answer. So the way to find the area of a triangle is to do 1/2 times base times height. What numbers would you use for this triangle? See if you can find the area of the front triangle. You can use a calculator. Pause the video. All right, hopefully you're ready. I see a right angle here. And the 2 numbers that make that right angle are 7.2 and 4.8. The 6 is not really involved with that right angle at all. So in order to find the area of that triangle, I'm going to do 1/2 times 7.2 times 4.8. And I'm going to type that into my calculator. Instead of doing 1/2, I'm going to type in 0.5. So 0.5 times 7.2 times 4.8. That gets me 17.28. Okay, so set the calculator aside. The back triangle is going to be exactly the same. So if you know it's the same, you could just copy down 7.28 again. That's because the 2 bases of a prism have to be the same. Now I'm going to erase my markings on my shape so I could show you the other sides. Let's look at left next. This is what I would consider left. Pause the video and see if you could find the area of that side. Okay, so hopefully you've paused the video and you've tried. This side is worth 6. And this side I could see is worth 10. So I'm going to use 6 times 10 equals 60. How about the right? To me, this is the right side. See if you could find the area of that. Pause the video. This happens to be another 6 by 10, but it's a different 6 than the one we used before. You cannot assume that left and right will be the same in a triangular prism. That only works for rectangular prisms. It happens to be the same, but it won't always be the same. Okay, I'm going to get rid of that. And now how about the bottom? Pause the video, take whatever time you need. See if you can find the area of this. So I would use 7.2 and 10. 7.2 times 10. If I multiply anything by 10, I just move the decimal over 1, so that's 72. Now I need to add up all those numbers. Pause the video, add up all the sides, and see what your final answer is. And you can use a calculator. So I got 226.56 meters squared. All right. So, let's see. How about number 3 next? I would start by setting it up with the same labels. Why don't you pause the video and find as many of the sides as you can? Come back when you're ready to see me explain some of them. Okay, so the first thing that I would do is I would figure out which side does not exist on this triangle. And again, it's going to be the top. There's no roof to this, really. So I can eliminate the top. The only 2 sides that I know are going to be the same are the front and back, because in this shape, that's where the triangles are. The triangles are the bases, so those are the 2 that I get to say are the same. In order to find the area of a triangle, I have to do 1/2 times base times height. The right angle is right here, so what 2 numbers make up that right angle? I can see that one of them is 8, and the other one comes from back here. It's 6. The 10 is not involved when I'm finding the area of the triangle. We never use the number that's away from the right angle. So 1/2 times 8 times 6. That equals 24. If at any point you feel like I'm giving you some clues and you want to pause the video and keep trying on your own, you can do that. I know the back's going to be the same because the 2 triangles have to have the same area. Now I'm going to do other sides. So left. What's difficult about left on this one is that you can't see it at all. It's this hidden side back here that's totally out of our view. So I have to think about what numbers would make that up. I think the bottom of the left side is going to be this right here, but over there. So I think one of the numbers I'm going to use is 12. And then the side of the left side is 8. So I think it's going to be 12 by 8, which is 96. That side's hard because you can't see it. How about the right side? Here's the right side. This one I can see. And it looks like I'm going to be using 6 and 12. 6 times 12 is 72. Then I still have the bottom to find. What numbers did you use there? I think I'm going to use 10 and 12. If you haven't yet, go ahead and add up the numbers. Even if you got different numbers, add up mine. And I got 336. Now, were you able to add units to it? If you didn't add units yet, add them now. Should have added centimeters squared. Did I add units on my last one? Okay, I did. I thought I maybe didn't. All right. Pause the video and try number 4. Okay, so hopefully you've given it a try. As I go over number 4, if you want to pause the video again and fix yours up, or maybe I gave you a clue that something was wrong, pause the video at any time and go and fix yours up. Since this is a rectangular prism, I'm going to have all 6 of these sides. And I know front and back will be the same, left and right will be the same, top and bottom will be the same. So I'm going to start with front and back. Think about what numbers you chose for that. I see that 9 and 3 are going to be my 2 numbers from front and back because this 3 is going to slide over here. So 9 times 3 is 27, which means the back is also 27. I can only assume this because it's a rectangular prism. If there was a triangle in here, I would not get to assume that. I'd have to actually look at it. How about left and right? So here's my left. Oh, that's actually my right. And left and right go there. I'm going to use 3 and 10. I was skipping ahead to the answer. That's 30. So both of these will be 30. and then top and bottom. I'm going to highlight the bottom. Maybe you highlighted the top. I think 9 and 10 look good for that. So I get to assume that they're the same because it's a rectangular prism. If you haven't added up the answers yet, go ahead and add them up. So when I add 27 plus 27 plus 30 plus 30 plus 90 plus 90, I got 294. Put in units if you haven't yet. Should be inches squared. All right, and we have one last one to do. So I see a triangular prism here, which means it's going to be missing one of the sides. Which side do you think it's missing? To me, I think it's missing the front. This little line right here, there's no front to it. There's just a line. There's a point, an edge. So I think there's no front. But I do see a back, a left, a right, a top, and a bottom. Pause the video, see if you can complete this problem. Come back when you're ready to go over it. All right, so I'm going to start with back. This is a rectangle. And I think back is going to be 14.5 times 8. This number and this number. And for that, I got 116. Okay, now how about left? Left is this. To me, that looks like here's a 10. And then for this side of that rectangle, I'm going to bring over this 8. So 10 times 8 equals 80. I wonder if right will be the same. Sometimes it is, sometimes it isn't. Here's right. And I think it's going to be 10.5 times 8. So this is not the same. We only can assume it's the same if everything's a rectangle. Once a triangle is in there, it throws everything off. So it's going to be 84. And now top and bottom. These two I get to assume are the same. Because in a triangular prism, the triangles are the bases and the bases have to be equal to each other. So I have two triangles here. The top triangle gives me information of where the right angle is. So I can bring that right angle down to the bottom triangle as well. So what two numbers make up this right angle? 10 and 10.5. So for the top and the bottom, it's going to be 1/2 times base times height, 1/2 times 10 times 10.5. If you use different numbers, pause the video and type that into your calculator and see if you can find the correct answer now. I got 52.5. So that means that's going to be the bottom two. Those are the only two sides we can say are the same. If you haven't already, add up your answers, put units on it.